calculate the heat generated by an electrical circuit in a calorimeter, you can use the equation Q equals volts times amps times delta T, where Q is the heat energy in joules, volts is the voltage across the circuit in volts, amps is the current flowing through the circuit in amperes, and delta T is the time interval in seconds over which the heat is generated. Now let's talk about converting a power under the curve graph to joules. The area under the power versus time curve represents the total energy. To convert it to joules, you need to integrate the power over the time interval. The formula for this is Q equals the integral of P of T dt, where Q is the total heat energy in joules, P of T is the power as a function of time in watts, and T is the time interval in seconds. If you have a power time graph on graph paper, you can use the trapezoidal rule to approximate the integral. This involves dividing the area under the curve into small trapezoids and summing their areas. The formula for the trapezoidal rule is Q is approximately equal to 0.5 times the quantity P1 plus P2 times delta T, where P1 and P2 are the power values at the start and end of each small time interval, and delta T is the width of each small time interval. Now, let's move on to calculating efficiency. The efficiency of the test circuit is calculated by dividing the output heat energy by the input energy. The formula for efficiency is efficiency equals Q output divided by Q input, where efficiency is expressed as a percentage or a fraction. Q output is the heat energy generated by the circuit, and Q input is the energy supplied to the circuit from the capacitor in joules. Remember that Q output is determined by using the first formula mentioned, or power under the curve method. To summarize, firstly, to calculate the heat, use the formula Q equals volts times amps times delta T. Secondly, to convert power under the curve to joules, use the integral of P of T dt, which can be approximated using the trapezoidal rule. Thirdly, to calculate efficiency, use the formula efficiency equals Q output divided by Q input. Remember that the accuracy of the power under the curve method depends on the resolution of the graph paper and the accuracy of your measurements. Smaller time intervals in the trapezoidal rule will generally yield more accurate results. Also, ensure consistent units throughout your calculations. Use volts for voltage, amps for current, seconds for time, and watts for power. A calorimeter itself is a device designed to measure the heat involved in a chemical or physical process. It's typically an insulated container filled with a known quantity of liquid, often water. The electrical circuit is placed inside the calorimeter, and the heat generated by the circuit is transferred to the liquid. By measuring the temperature change of the liquid, you can determine the amount of heat released by the circuit. When setting up the experiment, it's important to minimize heat loss to the surroundings. This can be achieved by using a well-insulated calorimeter and ensuring that the experiment is conducted in a draft-free environment. Also, make sure that the electrical connections are secure and that the measuring instruments are properly calibrated. The capacitor used to power the circuit stores electrical energy. The amount of energy stored in a capacitor is given by the formula E equals 0.5 times capacitance times volts squared, where E is the energy in joules, capacitance is the capacitance of the capacitor in farads, and volts is the voltage across the capacitor in volts. This energy is then discharged through the circuit, generating heat. The nonlinear voltage and current characteristics mean that the power is not constant over time. This is why integrating the power over time is necessary to accurately determine the total heat generated. When analyzing the power under the curve data, pay attention to the shape of the curve. A rapidly changing curve may require smaller time intervals for accurate integration using the trapezoidal rule. Also, consider any potential sources of error, such as measurement errors or heat loss from the calorimeter. If the voltage and current vary significantly over time, it's helpful to record their values at frequent intervals. This will allow you to create a more accurate power versus time graph. The power at any given time can be calculated by multiplying the voltage and current at that time. Consider using a data acquisition system to automatically record the voltage and current values. This can significantly improve the accuracy and efficiency of your measurements. The efficiency calculation provides a measure of how well the electrical energy is converted into heat. A lower efficiency may indicate that some energy is being lost due to factors such as resistance in the wires or heat dissipation from the components. Understanding the factors that affect efficiency can help you optimize the design of the electrical circuit. If you are getting unexpected results, double-check your calculations and measurements. Ensure that all the units are consistent and that the measuring instruments are properly calibrated. Also, consider any potential sources of error that may be affecting your results. To improve the accuracy of your measurements, consider using more precise measuring instruments. For example, a high-resolution voltmeter and ammeter can provide more accurate readings of the voltage and current. Also, using a more sensitive thermometer can help you to detect smaller temperature changes in the calorimeter. When using the trapezoidal rule, the accuracy of the approximation increases as the width of the time intervals decreases. However, decreasing the time interval also increases the number of calculations required. You need to find a balance between accuracy and computational effort. One way to improve the efficiency of the circuit is to reduce the resistance in the wires. This can be achieved by using thicker wires or by using wires made of a material with lower resistivity. Also, ensuring that the electrical connections are clean and secure can help to reduce resistance. Heat dissipation from the components can also reduce the efficiency of the circuit. Consider using components that are designed to minimize heat generation. Also, providing adequate cooling for the components can help to prevent overheating and improve efficiency. The type of calorimeter used can also affect the accuracy of the measurements. A bomb calorimeter is a type of calorimeter that is designed to withstand high pressures. This type of calorimeter is often used for measuring the heat of combustion of fuels. A coffee cup calorimeter is a simpler type of calorimeter that can be made from a coffee cup and some insulation. This type of calorimeter is suitable for measuring the heat of reactions that occur at atmospheric pressure. When analyzing the data, it's important to consider the uncertainty in the measurements. The uncertainty is a measure of the range of values within which the true value is likely to lie. The uncertainty in the heat calculation depends on the uncertainties in the voltage, current, and time measurement. The uncertainty in the efficiency calculation depends on the uncertainties in the heat input and heat output measurements. If the uncertainty in the results is too large, it may be necessary to improve the accuracy of the measurements. This can be achieved by using more precise measuring instruments or by repeating the experiment multiple times and averaging the results. In addition to the trapezoidal rule, there are other numerical integration methods that can be used to approximate the integral of the power over time. Simpson's rule is a more accurate method than the trapezoidal rule, but it also requires more calculations. The choice of numerical integration method depends on the desired accuracy and the available computational resources. The heat capacity of the calorimeter is the amount of heat required to raise the temperature of the calorimeter by 1 degree Celsius. The heat capacity of the calorimeter must be taken into account when calculating the heat generated by the circuit. The formula for calculating the heat generated by the circuit, taking into account the heat capacity of the calorimeter, is Q equals the mass times the specific heat capacity times the change in temperature plus the heat capacity of the calorimeter times the change in temperature. Where Q is the heat generated by the circuit, the mass is the mass of the liquid in the calorimeter, the specific heat capacity is the specific heat capacity of the liquid, the change in temperature is the change in temperature of the liquid, and the heat capacity of the calorimeter is the heat capacity of the calorimeter. The specific heat capacity of a substance is the amount of heat required to raise the temperature of 1 gram of the substance by 1 degree Celsius. The specific heat capacity of water is 4.184 joules per gram per degree Celsius. When performing the experiment, it's important to ensure that the calorimeter is properly sealed to prevent heat loss. Any heat loss from the calorimeter will reduce the accuracy of the measurements. Also, ensure that the liquid in the calorimeter is well stirred to ensure that the temperature is uniform throughout the liquid. The rate at which heat is generated by the circuit depends on the power dissipated by the circuit. The power dissipated by the circuit is given by the formula P equals volts times amps. The power is measured in watts. 1 watt is equal to 1 joule per second. If the power is constant, then the heat generated by the circuit is given by the formula Q equals P times delta T, where Q is the heat generated by the circuit, P is the power dissipated by the circuit, and delta T is the time interval over which the heat is generated. However, if the power is not constant, then the heat generated by the circuit must be calculated by integrating the power over time. The efficiency of the circuit can be improved by reducing the losses in the circuit. The losses in the circuit are due to resistance in the wires, heat dissipation from the components, and other factors. By reducing these losses, the efficiency of the circuit can be increased. One way to reduce the resistance in the wires is to use thicker wires. Thicker wires have lower resistance than thinner wires. Another way to reduce the resistance in the wires is to use wires made of a material with lower resistivity. Copper and aluminum are commonly used as conductors in electrical circuits because they have low resistivity. Heat dissipation from the components can be reduced by using components that are designed to minimize heat generation. Also, providing adequate cooling for the components can help to prevent overheating and improve efficiency. In some cases, it may be necessary to use a heat sink to dissipate heat from the components. A heat sink is a device that is designed to transfer heat away from a component. Heat sinks are often used with transistors, integrated circuits, and other electronic components that generate a lot of heat. The performance of the circuit can be affected by the temperature. As the temperature increases, the resistance of the wires increases. This can reduce the efficiency of the circuit. Also, some components may not operate properly at high temperatures. It's important to ensure that the temperature of the circuit is within the operating range of the components. If the temperature is too high, it may be necessary to provide cooling for the circuit. When designing the electrical circuit, it's important to consider the power rating of the components. The power rating is the maximum amount of power that a component can safely dissipate. If a component is operated above its power rating, it may overheat and fail. It's important to choose components with power ratings that are appropriate for the application. Safety is an important consideration when working with electrical circuits. Always disconnect the power before working on the circuit. Also, be careful not to touch any exposed wires or components. Electrical shock can be dangerous or even fatal. If you are not comfortable working with electrical circuits, consult a qualified electrician. When performing the experiment, it's important to follow all safety precautions. Wear appropriate safety gear, such as safety glasses and gloves. Also, be sure to work in a well-ventilated area. Be careful when handling the calorimeter. The calorimeter may be hot, so use caution when handling it. Also, be careful not to spill any of the liquid in the calorimeter. The data obtained from the experiment can be used to analyze the performance of the electrical circuit. The data can be used to calculate the efficiency of the circuit, the heat generated by the circuit, and other parameters. This information can be used to improve the design of the circuit. The experiment can be repeated with different circuits to compare their performance. This can help to identify the best circuit for a particular application. The results of the experiment can be used to validate a theoretical model of the circuit. A theoretical model is a mathematical representation of the circuit. By comparing the results of the experiment with the predictions of the theoretical model, the accuracy of the model can be assessed. If the results of the experiment and the predictions of the theoretical model are in good agreement, then the model can be used to predict the performance of the circuit under different conditions. The experiment can also be used to teach students about electrical circuits, heat transfer, and calorimetry. The experiment provides a hands-on learning experience that can help students to understand these concepts. The experiment can be modified to suit different levels of students. For example, younger students can perform a simplified version of the experiment, while older students can perform a more advanced version of the experiment. The experiment can also be used to demonstrate the scientific method. The scientific method is a process for investigating the world around us. The steps of the scientific method are observation, hypothesis, experiment, analysis, and conclusion. The experiment provides an opportunity for students to practice the scientific method.